Jump to the second page. Yesterday, our learning target was that we could analyze and graph parabolas. Today, our learning target is that we can write equations of a parabola in standard form. So we had this chart on the front page yesterday. We just added two equations to it. We said the focus is P units from the vertex, and the directrix is the opposite of P units from the vertex. Those could be summarized in the following equations. Focus equals vertex plus P, directrix equals vertex minus P. And obviously it only changes one coordinate, either X or Y, depending on which way it opens. So on this, it changes the Y coordinate because it's opening up or down. On this equation, it changes the X coordinate because it's opening left or right. So if we go to example 2, we did that yesterday. Example 3, writing the equation for the graph of a parabola with these characteristics. I'm going to zoom in so we can see letter A. All right. So they give us both the focus and the vertex, which is helpful. We're supposed to graph these also. I'm probably not going to graph them all, but I will graph the first one. For some of you, graphing it will help you figure out the direction. For most of you, you'll be able to just look and see which variable changes. In this case, it's the X coordinate. And you'll say, oh, the vertex is to the right, the focus is to the left, or no, I'm sorry, the vertex is to the left because it's at 1. The focus is to the right because it's at 3, so it's going to open to the right. But if you need to, you will have graph paper available for you to plot and check that. So 1, 2, 3, 1, 2, 3, 4. At 1, -4 is our vertex. At 3, -4 is our focus. The parabola always opens from the vertex toward the focus. So you know that this is opening to the right. So for some of you, it might just help to plot it to see which direction it opens. Because it's opening to the right, which variable will be squared in our equation? The y. So this will be a y minus k quantity squared equals 4p times x minus h. That's the equation when it's opening horizontally. The only values that I need in order to write the equation is h, k, and p. And so if I'm lucky enough that they actually provide me with some of these, then I can just plug them in and figure out what the other ones are. If not, then we have to calculate what they are and figure out some other stuff to figure out the values of h and k. In this case, they did give us the value of h and k, so that's nice. I'm just going to write this as x minus 1. We still have to figure out what the 4p is, and the y minus -4 will be y plus 4 quantity squared. So we almost have our equation, we just need to know the value of p. Well, the focus and the vertex can help us find the value of p. Since the focus is equal to the vertex plus p, if I want to solve for p, I just have to take away the vertex. Focus minus vertex equals the value of p. So I'm looking at my focus and my vertex. The y coordinates are the same. The x coordinates are what change. So that's where the value of p is going to be found because the y coordinates, it's the same height for both of those points. I could also count it on the graph, but I want to be able to calculate it with the points as well. So here I have focus minus vertex would be 3 minus 1, which is 2. Well, if p is 2, then 4p is 8. So I put that 8 in there, and I have my equation. Any questions on that? We're going to look at letter B, and then I'm going to have you guys try one, and then we'll look at letter C together. So for letter B, same idea, except this time they didn't give us the focus, they gave us the directrix. So we could graph that to see which way it opens, but I also know, look, it's the y. Y was 4 for the vertex, now it's 1 for the directrix. So that means that the y coordinate is what's changing. So that means that this is going to open either up or down. The directrix is always below or above the vertex. In this case, it's below, so this is opening up. If you're not sure of that, though, you can graph it. here's y equals 1. There's our directrix. Here's -2, 1, 2, 3, 4. There's our vertex. So yes, this graph is going to open toward the focus, away from the directrix. So I know that this one opens up. If it's opening up, which variable should be squared? X, yes. So x minus h quantity squared equals 4p times y minus k. Luckily, we already know the values of h and k, so that'll be minus -2, that'll be minus 4. So my equation now is x plus 2 quantity squared. We still have to figure out what 4p is, y minus 4. What's the relationship between the vertex and the directrix? The directrix is what? Yes, sir.
Wouldn't that be a y plus 4?
So it's a positive 4. I should have just wrote 4 there. I should have just put that we were plugging 4 in, and here we were plugging in -2. I put the minus sign there, which can look confusing. But had it been a -4, yes, it would be a plus 4. How do you find the directrix if you know the vertex and the value of p? Vertex minus p. So if I'm trying to solve for p, I'm going to add p to the other side, and I'm going to subtract the directrix. So p is vertex minus directrix. The vertex is -2, 4. The directrix is y equals 1. It's the y coordinate that's going to change. So I'm supposed to do vertex minus directrix, 4 minus 1. The value of p is 3, which means 4 times p is 12. And we have our equation. Take a moment to try letter D. Letter D is very similar to A and B in terms of, hey, look, they already gave us the vertex. That's awesome. We have most of our equation already written. We just have to find the value of P. So for letter D, you guys said it's going to be the x coordinate that's squared because it's the y coordinate that changes. Some of you even plotted the points for the vertex and focus to see that. The value of P can be calculated since vertex equals, since focus equals vertex plus P. P can be calculated by focus minus vertex. And what is that? What is 2 minus -1? 3. So again, the value of P is 3. So 4P is 12. And so our final equation for this one, since the x is squared, is x plus 6 squared, because minus -6, equals 12 times y plus 1. Any questions on how to write the equation if we're given either the vertex and focus or vertex and directrix? All right. Now we'll get to probably the hardest problem for graphing but writing the equations for parabolas, and that is when they don't give us the vertex. Sometimes they'll give us the vertex and the directrix, and we can figure out where the focus and the directrix, and we can figure out where the vertex is, because the vertex is halfway between them. But if they don't give us both, they only give us the focus and a point on the parabola, then it gets a little more complicated. So we do know that this one opens left. That tells us what our general equation will look like. Because it's opening left, we have a y equation. We've got y minus k squared equals 4p times x minus h. And unfortunately, we can't just plug the vertex in and quickly calculate the value of p. However, we do know that there is a relationship between the focus and the vertex. The focus equals vertex plus p. I'm sorry?
It says contains.
Contains, so it's not the vertex, it's just a point on the parabola. So I can't plug that, I don't want to plug that in for h and k. I could plug it in for x and y, but I can't plug it in for h and k. The vertex has a direct relationship to the focus with the variable p. The vertex is focus minus p. I'm using the same equation that the focus equals the vertex plus p. I'm solving for the vertex side, subtract p from both sides. So this key fact right here is going to help me write an expression for our vertex. Our vertex, since it's opening to the left, it's going to be the x coordinate that p changes. And that's because it's opening to the left, the x coordinate will change on the value of p. So right now it's 2. It's going to be 2 minus the value of p for our vertex. If I knew the value of p, I could easily find the vertex by subtracting it from the focus. The y coordinate of the vertex will be the same, just like it was for letter A above. When I graphed it, our value of p we found out was 2. If I had done 3 minus 2, I would have gotten 1, the x coordinate of the vertex. And they have the same y coordinate. So all I'm doing is rewriting this in terms of the focus and the value of p. That's the key step right there. That's kind of like step number 1 after you figure out which one's squared. So we have an expression for our vertex. I'm going to take this and I'm going to plug it in. This is going to be plugged in for h. This is going to be plugged into my equation for k. So now I have y minus 1 squared equals 4p times x minus, in parentheses, 2 minus p. That's all I did was plug in. Well, first off, I came up with an expression for the vertex in terms of p. So step 1 is express vertex in terms of p. So now we've substituted that in, but I have too many variables in here. I've got p and x and y. So what can I do? Any ideas? Plug in the 2 and the 5 for x and y. So this 2 up here will get plugged in for x. This 5 up here will get plugged in for y. That will give us 5 minus 1 squared equals 4p times 2. I'm going to distribute this negative. So it'll be minus 2 plus p. 2 minus 2 is 0, so I've got 0 plus p. So 4p times p is 4p squared on my right-hand side. On the left-hand side of the equation, 5 minus 1 is 4. 4 squared is 16. So I'm going to divide by 4. P squared is 4, which means that p is either 2 or negative 2. So by substituting in, or by figuring out the value, an expression for the vertex in terms of p, and plugging that in, and plugging in the point 2, 5, the x and y coordinates, we were able to write an equation that just had the value, just had the variable p in it. So we could actually solve for the value of p. Because this is opening to the left, it's got to be what? Negative 2, yes. So I now know that p is negative 2, which means 4p is negative 8. I also know I have an expression for my vertex. So if I bring that over here with the negative 2, my vertex is 2 minus negative 2, comma 1, which is 4, comma 1. And so now I can write my equation. Right? We have our equation right here. Bringing all that information together, the vertex, the value of 4p, and knowing which one is squared, we have y minus 1 squared equals negative 8 by x minus 4. So I'm plugging in the coordinates of the vertex and the value of 4p. This is not as simple as the other problems. It's not impossible, but it requires some steps, some substitution, and that first critical step of expressing the vertex in terms of p by doing focus minus p and substituting that in. I'm going to ask you to try a problem like this. I'm going to ask you to try letter E. Before you start substituting in, I want you to first decide what's the equation going to look like in general form. Will it look like this? Will it look like this? And figure out an expression for the vertex in terms of p. So take a second just to do that before we start building the equation. All right, let's take a look. So you know it opens down. If it's opening down, what's going to be squared? The x or the y? The x. So we've got x minus h quantity squared equals 4p times y minus k. Our vertex is related to the focus. Okay? Focus is vertex plus p. So vertex is focus minus p. So we're going to take the focus and we're going to subtract p from it, except because it's opening down, it's going to be the y coordinate that changes. So we will have, our vertex will be -3, -4 minus p. It's the y coordinate that changes since it's opening down. If it was opening left or right, it would be the x coordinate that changes. So we now have an expression for this. This will be our h, this will be our k. And I'm going to do this all at once just to save room. But this is going to be our x, and this is going to be our y. The 5 will be our x, the 10 will be our y. So I have 5 minus, and I'm going to do these ones in red because the equation above was pink. This will be 5 minus 3 quantity squared. Wait a second. It's minus -3, which makes it a plus. Equals 4p, because we still don't know what p is. We do know an expression for, or a number for y. Our number for y is -10. Minus, our expression for k is -4 minus p. That's going to give us, when I distribute this negative, it's going to be -10 plus 4 plus p. -10 plus 4 is going to be -6 plus p. And when I distribute the 4p, I get -24p plus 4p squared. On the left-hand side, I have 5 plus 3, which is 8, and 8 squared is 64. So I now have a quadratic that's going to help me solve for the possible values of p. So I'm going to do 0 equals, I'll put it in standard form, 4p squared minus 24p minus 64. I'm going to take out the greatest common factor of 4 to make it easier to factor. Minus 6p minus 8. So we've got p minus 8 by p plus 2, which means that p is either 8 or p is -2. Which direction was this opening again? Yes, sir.
Wouldn't that -8 be a -16?
Yes, it would be. What am I doing? Sorry. 64 divided by 4 is 16. Thank you. Which is why I get the 8 or 2. I was jumping ahead. Sorry. I was factoring in my head before my head was factoring before I finished writing out what I was writing. So it's either 8 or -2. So this is opening which direction? Down. Since it's opening down, which one do I need? -2. So this means that 4p is -8. So when we go to plug this into our equation, I'm going to put a -8 there. Our vertex, which we have an expression for right there of -3 comma -4 minus p. Well, p is -2. So that's going to be -4 plus 2, which is -3, -2 for our vertex. This gives us a final equation. I'm going to write it in this form. X minus h squared equals 4p times y minus k. Well, in this case, the vertex was -3, so that'll make this +3. -2 will make this +2. And the 4p will be a -8 in front. Questions on this problem? So when you get stuck on this one, you have to remember, you have to start by writing the vertex in terms of the focus and p. Focus minus p to get your equation. The assignment for this section for day 2 is coming from page 428. 20 through 24 even, that's only 3 problems. Those are like yesterday where you have to get it in standard form and graph it, just because there's going to be a lot of those that you're going to see on assessments and when you have a little more practice with that. And 27 through 43 odd. Those are more like today's problems, where you're building the equations from some given information.